And finally, let's discuss the notion of causality, which is that cause must precede effect as seen by any observer. Okay. For example, if I turn on a switch and this switch causes a fan to start rotating, every observer should agree on the time ordering. That is, the switch turns on first and then the fan turns on. Okay. Otherwise, the world would be very bizarre, right? Because some observers would see the fan turn on and then the switch getting flicked. So cause must precede effect. So we've seen that certain events, okay, certain events which lie in space-like separated regions from each other, do not preserve time ordering. That is, events which are space-like separated do not preserve time ordering. Okay. Events within the light cone, which are time-like separated, they do preserve time ordering. And so there's no not even a potential problem with causality there. But there is a potential problem with causality for events which lie outside of the light cone. Okay. So as we've seen, so let me just draw the space-time diagram again. So if we take a point P, which lies outside the light cone of O, then the events O and P are space-like separated, okay? And different observers may disagree about the time ordering of events O and P. So one could argue potentially that there is a potential problem of cause and effect. That is, if the event O causes the event at P to occur, then all observers will not agree on which event happened first. However, this is already resolved in special relativity by requiring that no signal from O can travel to P faster than the speed of light. Okay, or vice versa. So we could also draw the light cone at P. So the light cone at P would look like this. So this is the light cone at P. And obviously O and P lie outside of each other's light cones. And no signal from O, any signal from O would have to lie within the light cone. It cannot travel faster than the speed of light. The speed of light is the limiting speed for any signal sent from O. And similarly, any signal sent from P, either towards P or from P, okay, has to lie within the light cone, either the future light cone or the past light cone. So you see that there's no way that O can have a direct influence on P or P can have a direct influence at O. Both can be influenced by something in their past which lies within their past light cone. So some event in their past over here could influence O because it lies in O's past light cone, and it could influence P as well. But O itself, nothing happening at the spacetime point O, can have a direct influence on the spacetime point P. It could influence the future of P. So P at some time in the future would lie within the light cone of O, but this is a different space-time point, okay, which is the future of P. Let's call it some P prime. The point P itself is said to be causally disconnected from O. So O and P are said to be causally disconnected. That is, nothing happening at the space-time point O can directly influence P and vice versa. Okay, that is what happens when they lie outside of each other's light cones, or when O and P are space-like separated. So since O and P cannot have any causal effects on each other, the fact that different observers may record different time orderings for the events O and P is not a problem in special relativity. Okay, cause will always precede effect, but events which cannot have any cause-effect relationship do not necessarily have the same time order as seen by all inertial observers. So causally disconnected events do not have the same time order as seen by all inertial observers. Now, we have seen what happens to points P which are time-like separated from O, that is, which lie within the future or past light cone of O, and events where P lies outside of the light cone of O. But what if P lies on the light cone of O? So if O and P are light-like separated, then the first thing that we've seen is the space-time interval between them is 0. So if we interpret this as if we imagine that we're in a frame that is moving with a speed almost equal to or equal to the speed of light. So in the limit where we have a frame where the t prime and x prime axes are getting squeezed closer and closer to this light cone, in the limit where the speed of this frame goes to c, in the limit where beta goes to 1 of the frame s prime, the x prime axis and the t prime axis would actually coincide. And therefore you can interpret this point P as either being separated in time. So if I write the spacetime interval as c squared tau square, the proper time that has elapsed on a clock is 0. That is, a stationary clock at O has recorded that no time has passed till the event P. Or if I think of this as separated along the spatial axis x prime, then I can write this as c square, I can write this as minus sigma square. And sigma is 0. That is, the events O and P occur at the same point in space. So for in the limit of a light beam, if you're in the frame moving with a light beam, time would appear to come to a standstill, and space would all shrink down to a single point. Okay, so this is a very bizarre limit of special relativity, where time and space appear to come to a standstill.